Hello, thanks for joining today. The presentation is on the reverse engineering extension, also known by its cool nickname, which is Rex. So what will we cover today in the agenda? We'll cover what the reverse engineering extension is and how it benefits you and your company. Before we get started, my name is Bill Drosos. I am the Industrial Design Application Engineer here at PDSVISION, North America. What is the reverse engineering extension, or what is Rex? Rex enables the conversion of existing products into CAD models. It enables the productive reuse of intellectual property and allows engineers to work with point cloud data obtained by scanning physical prototypes. How does it benefit you and your company? Well, it allows you to create an exact copy or almost exact copy of existing physical products, allows you to optimize the reusability of existing designs and leverage of the discontinued or hard to find designs. Now, the point cloud data that you bring in can also be refined in such a way that you create precise surface geometry. At the end of the day, we're looking at great quality surface geometry. That's really needed for good looking products, right? It also allows you to respond more effectively to market demands, and in the end, you really do save a lot of time and money. Okay, so now let's take a look at the import options and tools that we have with the reverse engineering extension. So I'm going to go to my Get Data group and import some point cloud data here. And before we click OK, we'll choose the facet node. Okay, so my points come in pretty dark against my dark background, so they're harder to see, but if I box select these, we see that we have the sphere point cloud and also some floating points in space there. So to get rid of those floating points, there's a neat tool called delete outliers. So if I select that, I can experiment with a different sensitivity level between 0 and 1. I'll keep 0.5 for now and select preview. And you can see that's going to just select those outliers. And if I click OK, it's going to get rid of those. So now when I box select the sphere again, you can see that we have a nice clean sphere now. Okay. I can also select the point data. So I can go into my selection tools and I can use my inside cross box and select the portion of the points. I can use my polygon selection tool or my paintbrush tool, for example, to select points. Okay, we also have what's called crop selected. So what I'm going to do is I'm going to box select some of the sphere and I'm going to go select crop selected. So that's going to remove everything except that which was in my cropping box selection. So it basically does an inverse selection, right, or deletion. So instead of deleting the portion that I enclose in that box, it's going to keep that portion and remove the rest of the point cloud data. All right, I'm going to undo that. So now we have our sphere back. Of course, we have delete selected. We talked about if I select some of this point cloud, I can hit delete on my keyboard or hit the delete selected up here. All right. I also have this fill hole option. So maybe if I grab like a portion of this sphere down here and delete that portion of the sphere, right, I can select it and say fill hole, and now that portion that I deleted is filled back in with geometry. So that's pretty powerful as well. I'll undo that. So after we refine the point cloud data to our liking, we can then take it into the facet feature, and that basically converts the point cloud data to faceted data. All right, and in here I have the same selection tool. So I have my inside polygon paintbrush, for example. I've got my fill hole. So if I delete a portion of this mesh, I can go to my fill hole and say, hey, I want to select that portion and fill it in. And now that's filled in. Okay. We also have refine mesh, and that will help to basically add more geometry to the mesh to refine it further. So that adds detail slash resolution to the mesh, right? So if I go in here and say, hey, let's add a 4x subdivision and click preview, you can see it adds a lot more polygons, right? If I box select this now, let's go ahead and choose our inside cross box selection. You can see it added 4x the amount of polygons in that area, right? So I'll undo that. Then I'll fill in my hole again. Make sure I select it first. Okay, great. I also have the option to create triangles or polygons, right? So there's add facets. I can come in here and click the endpoints of the mesh and create some polygons. And start cleaning the mesh up here. All right. Now, of course, I don't like this condition too much, so I go back in there and fix that and clean it up. So maybe I add my facet again, but I'll grab these first and then those three. Okay, so now I have a lot cleaner condition here. I can choose whether I'm selecting the front facets or the back facets. There's relax, so if I have a lot of geometry kind of poking out or sticking out, that relax option will help bring that down and smooth it out a little bit. And then we have decimate as well, so I can say, hey, you know what, I want to keep 50% of this mesh, for example. If I select preview, you see it just reduced the amount of polygons, and I can do it again. I can do 10%, for example, and select preview. Okay? So if you have too many polygons, you can reduce the amount by using the decimate tool. Okay, so now let's shift to a more realistic product like the Snowmobile here. This is the Polaris Snowmobile, and we are tasked with reverse engineering some point cloud data for the seat. So I'm going to start off by selecting the seat geometry and opening that up. Let's hide it. So I'm going to shift select these and suppress that for now. Let's go to get data, import, and I'll select my points and import those with the facet node selected. So now we have our seat point cloud data that you can see here, and it's pretty dense, right? So we have a ton of points here that we're working with. The first thing I'm going to do is use the sample tool, and again, if I select the sample by curvature node, what this will do is based on the percentage that I give it, it will reduce points in the more planar surface areas that don't really need more points to define the curvature, and it will either keep or add points in the areas where there is more curvature so that it's defined enough to create a high quality surface in those areas. So I'll use the 85 percentage here and click OK. You'll see it update there in front of us. Once I do that, it's pretty clean at this point. So let's go to the facet mode, right? And at this point, what I'm going to do is I'm going to search for some holes. So I'm not concerned about the bottom edge loop there because the seat's supposed to be open in that area. And I'm going to choose this hole and fill it in. Okay. Now, in order for us to use the restyle tool, which is the reverse engineering tool in Creo, this has to be a manifold mesh, which means it has to be clean. You can't have faces that overlap each other or intersect each other. So I'm going to select the Make Manifold tool. And in this case, I'm going to use open because this isn't a closed mesh. So if I click OK, it's going to clean this up and make sure that the geometry is good enough for restyle to use. And I'll click OK in a second time. So before I even get into the restyle tool here, I'm going to go to my freestyle tool. A lot of people don't know that if you purchase the reverse engineering extension, you get an additional tool added to your freestyle dashboard. So for example, if you just have the base seat of Creo, you get freestyle and all these primitive shapes that you can bring in and manipulate, and start sculpting with, right, to create your product concepts. But again, with Rex, you get this reconstruct from facets. And what's great about this and powerful is if I select it and then select my mesh, I get to choose the resolution level that the reconstruct from facets will recreate this data at. So I'm going to select the third option or the third level and then click OK. And it's going to process. Shouldn't take that much time. My computer is pretty beefy. It'll get going here shortly. There we go. How cool is that? Look at that. Look how close that is to the original shape. I'm going to hide the original faceted data. So it basically created curvature continuous B-rep geometry from the imported faceted data of the seat. Now, what I also love is that, let me go into my top view. I'm going to select some of this geometry on the seat, and let me select the rest of this portion here. Okay. And I'm going to move the drag tool. I'm going to relocate it to my top plane here. So now, with the back portion of that seat selected, I can take this seat and drag it. So look how easily and quickly I was able to extend the length of that seat. Imagine how much more time that would have taken using the default Creo surfacing tools, right? I could also now come in here and subdivide the seat further, right, to add more geometry. What if I wanted to add some style to this seat, right? I could select geometry. Maybe I grab these faces. I'm going to grab some more. Let's do that. And one more row. Then I'll create an inset. Now watch what I can do. I'm going to relocate the drag handle to that edge, and I'm going to rotate this back. Isn't that cool? So look how quickly I created that little groove or indentation in the seat, for some styling. And if I wanted to, I didn't do this, but I could have enabled my mirror, and that would have mirrored anything that I modified on the front side here to my back side. Okay. Okay, great. So I just wanted you to see that there is this other aspect of the reverse engineering extension within the Freestyle tool that's pretty powerful. Okay, so now let's take a look at the actual Restyle tool. We'll select the mesh first to get started. Okay, so we have, of course, curves that we can use to create curves on top of the faceted data. We also create surfaces. Let's start off with some curve types here. So we have on-facet curves, through snap points, cross-section, from facet border. So let's start off by using the cross-section curve. I'll select that and then select my right plane, and it created a blue curve you can see there from the intersection of the plane and the faceted data right down the middle. Okay, in here we also have the from facet border. Notice that if I zoom into the border now, of the seat towards the bottom, it'll highlight the edges, and I can select that edge, for example, and start creating a curve along the edge here. All right. What a powerful feature. I'm going to delete that edge for now. And I'm going to show another curve type, which is called on facet curve. And I'm going to start off by creating a curve at this endpoint of that cross-section curve. And just follow this geometry, creating points along the surface. Like that. I can also modify this curve. So if it's not straight enough for something, I can select the curve and go to modify shape, and I can start moving some points around. Right now it's on smooth region. I can go to local, and this is a lot easier. I can start to come in here and modify these points. I can delete points too, as well. All right, if I go back here, I can click delete and then select the points I don't need. So I've got way too many points, right? So it's easy to come in here and reduce the amount of points. And I can create a surface by just selecting 4 corners. So I left click there, create that point, hold control, and then create a point there, then a point here, and a point here, right? And just like before, I can modify my UVs to match the previous surface, like that. Click OK, select that surface, and then project it onto my mesh here, right? Pretty powerful stuff. Now, it looks like I went too high in this area, so again, I could always come back in here and grab that curve and modify its shape, right? And pull it down, for example. So I can take these points and modify where they're at on the mesh. Redistribute those points. There. Or in some cases, right, it might just be easier to come in here and recreate that mesh, right? So there's a curve in this, but I'm going to try to not select where the curve is so that I can capture this a different way. Okay, now what's great about using this surface creation method, let me reduce these first and project. The great thing about this surface creation method is it allows you to easily extend the surface within the reverse engineer or within this freestyle tool. So with the extend option, I can take this surface, select it, and extend that side out and extend this down further if I want to. And of course, we want to do that because I need to merge these surfaces together or trim them, right? So I can't extend the surface that I created using the curves, but I can extend the surface if I'm using one of the surface options below, like box, corners, and midpoints, right? So now if I click OK, I can use Creo's default extend tool up here and then select this edge, for example, like that. And now you guys know that what we can do is we can merge these together. So I can grab my merge tool, select that surface and this surface, click OK, and there we go, right? And look how close that is to the original tessellated data. Pretty close, right? Okay, great. So now let's take a look at some curve tools and some other surfaces that we can create. So the first thing I want to talk about is the split tool. So we have this curve right here, but let's say, for example, we had to split that curve into two separate pieces. There's a split feature in the curves group. If I select that, I have to first select the curve and then a point somewhere along the curve. And if I do that, I get two separate curves, right? I could also combine two separate curves with the combine tool. So if I select the combine tool, I'll select the first curve, then the second curve with control, and now we have one curve made from those two separate curves. Okay. Notice that we have domains created, which we've talked about before. There's another surface type called surface from net. And basically, that allows you to create or to select as many curves as there are in the first and second directions for creating your four boundary surface. So, for example, I've got, one, two, three, four boundaries here, boundary curves, but I also have some internal curves. So I have this internal curve in that direction, then I have this internal curve here in this direction, right? So I can use net now to, select this network of curves to create the surface. So I'll select the curves in the first direction. So I'll select that first one, the second, and the third. Middle mouse click, and then in the opposite direction as well, like that. And there's our surface. And of course, we can now select project and select the surface to align it to the faceted data. So now if you're wondering if you can control the tangency between two curves or two surfaces, you can. To do this for curves, you want to use the alignment tool. So I'll go to alignment, and I'm going to make this curvature to the previous one. So I'll select the curvature node, and I'll select this curve and the adjacent curve. And now you see that we have curvature continuity between them. I'll quickly create my surface here. And now let's adjust the continuity between this surface on the left and the surface on the right. So to do that, we first have to display the constraints, select a surface and middle click, and we get these arrows. If I select an arrow and right click, it'll tell us the continuity. So currently it's at tangent, but I can adjust it to curvature. And when I do that, you see that we get these two arrows aligned closely to each other there.
Okay, so now that we've seen the restyle tool, let's now take a look at what we do once we've created these nice clean surfaces using the restyle tool. So as you can see, we have restyle 4, which we created, and if we come in here, we can unhide the faceted data, right? And we've created these nice clean surfaces using the methods that I showed before. So we'll exit out of here. And it's simply, if you guys remember going back to the extending and merging of the surfaces, this is what we're going to do here. So we're extending the surfaces out, making sure that they intersect each other. Then after that, we're going to continue to merge them together and add rounds in this case. Extend, extend. We can just kind of go step by step here. And adding our rounds and then merging, mirroring over, okay, great. So the idea here was to capture the surfaces of the original test-slated data as closely as possible with the restyle surfaces, and then extend them, merge them together, and then add the rounds to get this result that we see here. Okay. Now there's this other tool called Style, which basically comes from the Interactive Surface Design extension, and this feature is also great for reverse engineering. So let's go ahead and just suppress all this nice work that we've done like this, and we'll unhide that tessellated data. Okay, so the style feature is up here in the surfaces group above freestyle. And if I select that, it's going to take me to this surfacing environment. And this surfacing environment is great for those that have used Alias and Rhino that are more on the industrial design side, but it's also great for reverse engineering. Okay, so let's now take a look at creating a surface from the tessellated data using the style feature. Okay, so within the style feature here, there is a curve tool, and within it there are 3 curve types. There's free curve, planar curve, and curve on surface. Now you may think that we'll be using curve on surface here, but we're not going to use that. That will allow us to create curves on the tessellated data, but if I turn on the tessellated data, you'll see that if I use curve on surface, we would have to basically create curves between every one of these polygons, starting and stopping for each polygon, and that would just take way too long, and getting a nice clean curve from that would be almost impossible, right? So we're not going to use that tool, but we will use the free curve. Okay, with free curve, it's nice because you can hold the shift key down and you can left click to snap a point to the tessellated data. So I'm just going to hold shift here, snap, and just create points along the tessellated data. And I'm going to create 4 boundaries here. So I'll create 4 boundary curves. Try to get this as smooth as possible. But we can always go back later and smooth it out. So let's go ahead and create the last 2 curves here. Just 1 more left. Okay, so again, these points of the curve are snapped on that tessellated data. So let's just say, we needed to refine this curve more and add more points that are snapped to that tessellated data. We can do that. We can right click here and say add point, for example, then select the point, hold shift, and snap it to that tessellated data. So it's very easy to add more geometry and detail to this to get the surface that you need. I can also come back in here and modify the shape of the curve to get it where I need it to be. All right, so yeah, once I have my curve selected, right, now I can go in here and I can grab my surface feature and select the boundary curves. And there it is. There's my surface feature. You also may be thinking, well, hey, that's not close enough. I do have the option here, let me hide the surface, to add more curves, and I can add what we call internal curves, right? So I can go in here and now create a curve in this direction. And then also in this direction. Okay, so if I want to redefine the previous surface that I created to include those internal curves, I can now select the surface, add definition, click my internal chain collector, and then select those internal curves. And now you can see it matches that surface even closer than before. All right, I can hide my faceted feature, and there's a nice clean surface. Okay, so that's about it for me here as far as showing you guys the reverse engineering tools within Creo. Hope you guys really enjoy the webinar, and if you have any questions, feel free to reach out to our team. Thanks a lot. Bye.